Okay, so we're going to be having a look at parametric integration. Now, the problem with parametric integration is that we are integrating things in terms of t. Okay, or it could be in terms of t, it could be in terms of anything. Usually, for parametric, it's in terms of t, which represents the time, doesn't it? Okay, if we look at that area is equal to the integral of y with respect to x, the problem with that is that it's with respect to x. Okay, however, we want it with respect to t. So what we do, I mean, you shouldn't really think about it like this, but the way this works is we've got the integral of y dx by dt. Okay, that's how you integrate a parametric equation in terms of t. Now, if we think about what that means, we do y times by the differential of x with respect to t, and then we can integrate that in terms of t. Does that make sense? Everybody should be getting this part here down. This part here is the important part. Okay, so here's the question. Determine the area between the curve with parametric equation x is equal to t squared, y is equal to t plus 1, between x is equal to 0 and x is equal to 3. Okay, now there's a few issues with this. The first issue is that we've got x and y in terms of t. Now we could, if we want, what's one way we could deal with this? What's one way I could deal with this? Make it into a Cartesian equation, yeah, by substituting these in. Well done. Yeah, you can make this into a Cartesian equation. You could do that, but we're not going to do that now, okay? We're going to use the highlighted formula, which is y is equal to, sorry, it's the integral of y dx by dt. Now, the problem with that is our x values are in terms of x. We need them to be in terms of t, so we also need to change our boundaries for that as well. Okay, so actually the first thing I'd probably do here for this one is change my limits. So we know that x is equal to t squared, so t is going to be equal to the root of x. Now we've got to be careful with that. Why have we got to be careful with that? Because you're going to get plus or minus with that, okay? We are going to get plus and minus with that. And we do need to consider that sometimes, okay? I don't think we're going to consider it in this case because t time is going to be a positive value in this, but we may need to consider that going forward. So okay, let's find out what dx by dt is first. So dx by dt is equal to what? 2t, yeah, good, we know that. Y is still equal to t plus 1, we know that. Okay, and our limits are 0 is equal to t squared, so in which case t is equal to 0, or 3 is equal to t squared, in which case t is equal to root 3. Okay, so I now need to substitute that in to our formula, which is it's the integral of y dx by dt. So it's going to be the integral between 0 and root 3 of y, which is t plus 1, times by dx, which is 2t, with respect to t. Everybody all right with that so far? So this is going to be the integral between 0 and root 3 of, you definitely need to expand this out, 2t squared plus 2t dt. Okay. So if I integrate this, I'm going to get 2t to the power of 3 over 3 plus 2t squared over 2, which is equal to t squared, all between root 3 and 0. So this is equal to 2 root 3 all cubed over 3 plus root 3 all squared minus, well, that the other one's going to be 0, isn't it? Because it's 0 and 0. Yeah, we'll do it just so I can show. 2 times 0 cubed all over 3 plus 0 squared like so, which is going to be 0 and 0. So it's going to be, well, that's going to, root 3 cubed is equal to 3 root 3. So the 3 root 3 is going to cancel there, so it's going to be 2 root 3. So it's going to be 2 root 3 plus 3. I've done a bit too much in my head there. Is everybody alright with where that's come from? Cubing that root 3 is going to be 3. Root 3 times root 3 times root 3. Root 3 times root 3 is 3. Times by root 3 is 3 root 3. The 3 on the top and bottom will cancel, so it just leaves you with 2 root 3 plus the 3. Yeah? Let's check that. 2 root 3 plus 3. Brilliant. Everybody alright with that? Super. Here's another example. So let's have a look at this one together then. Or do you want to have a go at it? It's up to you. Do you want me to do it? Or do I have a little go? Well, you get started. I'll give you a second to get started and then I'll have a go at it. Do you want me to start having a go at it? See if I can catch up? Are you okay? Do you want me to start having a go? Yeah? This is a hard one, I think. Okay. So, what things do we need? Well, we need dx by dt. Now, the problem with that is I need to expand this out. So let's just expand that out first. So it's going to be t plus t squared. So dx by dt is going to be equal to 1 plus 2t. Everybody all right with that? Okay. Y is equal to 1 over 1 plus t. We're going to get two values here. Now, we do need to be really careful when we're finding out these values, okay? So when x is equal to 0, we end up with, and I'm just going to put this over here, we end up with 0 is equal to t times by 1 plus t. Now, usually in the question, what they do is they tell you that t is greater than or equal to 0. It's not necessarily always the case, okay? They would usually tell you this. Oh, it does, literally there. So it tells you that t is greater than or equal to 0. So in which case, we know we've got two solutions. One is equal to -1, but actually the other one is equal to 0. So for the first one, we end up with t is equal to 0, yeah? The other one is a little bit trickier because it's 2 is equal to t plus t squared. So in which case we end up with 0 is equal to t squared plus t minus 2. So we're going to end up with plus 1 and minus 1, is it? No, plus 2. No, plus 2 minus 2. So in which case my solutions are t is equal to 1 and minus 2. But we know it can't be minus 2. Okay? So we've got our values of t. The next thing we need to do is to sub it into it's the integral between 0 and 1 of y dx by dt, which is equal to the integral between 0 and 1 of y, which is 1 over 1 plus t, times by dx by dt, which is equal to 1 plus 2t, is it? Everybody happy with that? dt. Now, they've given us a massive hint here. You would never get this hint in the exam, okay? And their hint is they're saying, recall that to integrate top every fraction, we need to use long division first. Okay, they've given you that hint. So this is the integral between 0 and 1 of 1 plus 2t all over 1 plus t dt. So we're going to have to use here long division. Okay, it seems nasty, doesn't it? So 1 plus t, I'm going to change that around actually. So I'm going to go t plus 1. How many times does that go into 2t plus 1? Well, how many times does t go into 2t? Twice. 2 times by t is 2t. 2 times by 1 is plus 2. When I subtract those, I end up with minus 1. So what I'm integrating here is I'm integrating between 0 and 1, 2 plus minus 1 over t, 1 plus t, or t plus 1, whichever way around you want to put it, with respect to t. Everybody all right with that and where it's come from, yeah? We're starting to really get into the tricky nitty-gritty here, aren't we? Because you've got to be able to spot that you are using long division there. So this is equal to 2t, integrating that, minus ln of t plus 1 between 0 and 1. So it's going to be 2 times 1 minus ln of 1 plus 1 minus, open bracket, 2 times by 0 minus ln of 0 plus 1. What is ln to the power of 1? Anything to the power of 1 is 0, so that's going to be 0 as well, isn't it? That's right, isn't it? ln1 is 0, isn't it? So I end up with 2 minus ln2. There we go. I love these questions. Yeah. What's that, sorry? Do I need... Oh, yeah. But because it's 2, you don't really, if you know what I mean. It'd only be mod if it was a variable which could be negative. Does that make sense? Yeah? So because it's mod ln2, it can just be ln2. Does that make sense? Because you're basically modding a positive value. Yeah? Everybody alright with that? Yeah? Cool. Alright, here's a question for you to have a little go at yourself. Have a go at this one yourself. It's worth 10 marks in total. Okay? Worth 10 marks in total. You want me to start having a go? You okay for now? When this came up in 2013, 13. I actually remember it really well because people panicked because of the 2t. They treated it like an e. Yeah? Integral of e to the t is e to the t. The integral of 2t, we have actually done this, is 2t ln 2. Sorry, differential of 2 to the power of t is 2t ln 2. The integral of 2t is equal to 2t over ln 2. Here, the helping hand bit. Can we start going through it? Okay. So first of all, we need to show that A has a coordinate of 0, 3. Now we know that A is when x is equal to 0. Okay. So for part A, where shall I do this now? So for part A, when x is equal to 0, so it's going to be, so let's just write both of our equations down. It's going to be, let's write them here. X is equal to 1 minus a half t. Y is equal to 2t minus 1. So when x is equal to 0, we end up with 0 is equal to 1 minus a half t. Take that over, times by the 2, we end up with t is equal to 2. So then we need to sub that into here, which is going to be equal to y is equal to 2 to the 2 minus 1, so y is equal to 3. Okay, which gives me my coordinate, which is 0, 3. Everybody alright with that? Yeah, everybody alright with that? Cool. So that's part A. We know that B is going to be when y is equal to 0. Okay, so we sub in y is equal to 0, which is equal to 0 is equal to 2t minus 1. So take the 1 over, we end up with 1 is equal to 2. Well, let's take the 2t over. We end up with 2 to the power of t is equal to 1, which is going to be equal to log base 2 of 1 is equal to t. What's anything to the power, what's anything log 1? 0, so t is equal to 0 at this point. So let's sub 0 into there, into the other one to find out our x coordinate. So x is equal to 1 minus a half times by 0. So x is equal to 1. So our coordinate here is equal to 1, 0. Everybody alright with that? So thumbs up, thumbs middle, thumbs down. Good, good, good. So that's part B. The next part we need is to then do the integration of this. So let's give myself some space. So let's write down what we've got. We're doing it between, what is it, -1 and 1. So it's the integral between -1 and 1 of, well, first of all, we need to find out what our t values are. So we're going to have to sub those into, well, let's write down what x is first. So x is equal to, zoom out a bit, 1 plus a half t. Y is equal to 2t minus 1. So if we know what our limits are between -1 and 1. So it's going to be -1 is equal to 1 minus a half of t. So bring that over, bring that back. It's going to be a half t is equal to 2. So t is equal to 4. Everybody happy with that? Apart from my computer. Okay. Annoying. So, where was I up to? I wrote down x is equal to 1 over 1 minus a half t. Y is equal to 2t to the power t minus 1. I said that we're trying to find out when x is equal to -1. So -1 is equal to 1 minus a half t. Bring that over, bring that back. And times it was t equal to 4, was it? T is equal to 4 when x is equal to -1. When x is equal to 1, it's going to be 1 is equal to 1 minus a half t. Take that over, bring that back. It's going to be t is equal to 0. Now, just before I continue, what do you notice about that? Is there something in particular that we need to spot there? On our first one, we've got x is equal to -1 and t is equal to 4. And then we've got x is equal to 1, but t is equal to 0. What's the problem with that? It's not a problem, but the 4 usually goes at the top. Okay? Usually you put the bigger number on top. Here, we have to follow our limits. Okay? So our limits, so 4 needs to go on the bottom and 0 needs to go on top. That makes sense why that is. Because my limits of x are -1 to 1. So in which case, it needs to be from 4 to 0. Okay? Does that make sense why that is? Yeah? You sure? Okay. So, now I also need to find out the differential of dx. So that's going to be equal to dx by dt is equal to just -1/2, is it? Yeah, everybody right with that? So it's going to be the integral between 4 and 0 of y, which is 2 to the power of t minus 1, times by -1/2 with respect to t. Everybody right with that so far? Now, if this was me, which it is, I would probably take out that -1/2 as a constant from my integral. Okay? You can actually take constants out of integrations. So I would write it like, and you don't have to do this, but you can do. So I would write it as -1/2 is the integral between 4 and 0 of 2t minus 1. It's only a factor of everything that's in there. Okay? You all right with that? So then I need to integrate this. So it's going to be -1/2. The integral of 2 to the t is going to be 2 to the t all over ln2. Everybody right with that? That's from the little hint I was just talking about before. The integral of a to the x is a to the x over ln a. You will need to know that. Okay. Minus t between 4 and 0. Okay, so then take note that minus a half is times by everything. So you've got to work out the first part, you've got to work out your boundaries, and then you've got to times by negative half. So this is equal to minus a half times by 2 to the 0 over ln 2 minus 0 minus 2 to the 4 all over ln of 2 minus 4. Okay, so 2 to the 0 is 1. So I end up with minus a half or times by 1 over ln of 2 minus 2 to the 4 is equal to 2, 4, 8, 16. 16 over ln 2. Plus 4, minus minus. Everybody right with that? Where that's come from? Which is equal to, so 16 minus 1 over ln 2 minus 16 over ln 2 is equal to minus 15 over ln 2. So that's going to be equal to, times that by minus a half, it's going to be positive 15 over 2 ln 2 minus 2. Everybody right with that? A lot going on there. Okay. Yeah. What's that? What's that? Sorry? Minus a half times. Which is correct. It's not easy that. It's not easy that. Let me just.